Fine. So now we are going to do the problem. Determine the centroid for the whole area shown. So this is the I section. First thing is I section. Do we derived any formula? We don't derive any formula, right? Okay. Then what I can do? I can divide this I section into number of rectangles. 1 rectangle, 2 rectangle, 3 rectangle. Rectangle I already know the formula. X bar is b by 2, y bar is d by 2. Simple. Right? We'll go with the step for centroid. First step is drawing of reference axis. Okay. So to do the reference axis, we should see symmetry, point of symmetry. Okay. So I'll take most of the time, I'll take this reference axis to be at the bottom. It's my wish. Centroid always with respect to reference axis, and I can take the reference axis. I'll take always at the bottom is the reference axis and leftmost is the reference axis y. Okay. So here for this whole I section, what is x bar? X bar is the distance from reference axis y to the centroidal axis yg. So now reference axis y is there. Where is the yg axis? I don't know where it is. That is what I need to find out. So mostly centroid will be at the center, right? I'll just assume it and I'll draw this axis xg, yg. Okay. Now can you mark x bar? Yes. Y to yg is x bar. X to xg is y bar. Fine. I have marked first step is over. Second step is you have to see whether it's symmetry or not with respect to anything. For example, if I cut with y axis, both is similar. So it is symmetrical about y axis. Yes, it is symmetrical about y axis. If it is symmetrical about y axis, you don't need to calculate x bar. Directly you can get it. X bar is what? Distance from reference axis y to the centroidal axis yg. See, for this first rectangle x1, the distance from reference axis y to yg, local axis yg. What is the distance? 150 divided by 2, 75 mm. I'll draw here for clarity. This is local G, this is reference axis. Okay. This is reference y axis, this is reference yg1 axis. What is the distance from here to here? Exactly at the middle, 75 mm. X1 is 75 mm. For next rectangle, you try for this next rectangle, okay? This is my next rectangle. This is my reference axis y. This is my yg2 axis. This yg2 at the center. This also same only, right? Because it is symmetry, that's why. What is x2? Same thing. From here to here, what is the distance? 75. Similarly, for the third rectangle you take. Here, from here to here is the x3. Same point only, right? yg3. What's the same point? No problem. Same. Because it's symmetrical about y axis. So if it is symmetrical about y axis, I don't need to calculate. x1, x2, x3 are same. So what is x bar? 75 mm. But y bar is not like that. If I cut with x axis, this is different, that is different. So I have to calculate y bar. It's symmetrical about y axis, so x bar I don't need to calculate. But it is not symmetrical about y axis, sorry, x axis. Not symmetrical about x axis. So I have to calculate y bar. What is the formula for that? Already we derived the formula by method of moment. A1, y1. Depending upon the area. Here how many areas were there? 1, 2, 3 areas were there. So A1, Y1, A2, Y2, A3, Y3, divided by A1, A2, A3. Okay. Now fastly I will explain it. What is Y1? What is Y1? Y1 is the distance from reference axis X to the local centroidal axis xg1. For example, here you see this is x axis, local centroidal axis will be here. What is the distance? 20. The whole thing is 20. So 20 divided by 2, 10 mm is Y1. 10 mm. What is Y2? Distance from reference axis X, local centroidal axis xg2. What is xg2 here? This is reference axis X, xg2. What is the distance from here to here? This is exactly at the middle. 100 divided by 2, 50. From here, what is the distance? 20. Always with respect to the reference axis. X to xg2. From here to here distance. From here to here is 20. This distance at the middle because it's a rectangle. Rectangle means this half the distance only, it's centroid, local centroid will be there. So 50 plus 20, 70 mm. Can you tell me what is Y3? Simple. X reference axis, xg3. What is the distance from here to here? It's 20 plus 100 plus half of this distance, 10 mm. Right? Fine. Now I'll explain it. Okay. So 20 plus 100 plus, I'll go to this point. Now only xg3 axis is coming. 20 plus 100 plus 20 divided by 2. So 120, 120, 130 mm. Now I calculated Y1, Y2, Y3. You have to substitute here. What is A1? A1 is what? Area of a first rectangle. So first rectangle is 150 into 20. What is the Y1? From here to here, 10 mm. What is A2 value? 20 multiplied by 100. This rectangle. Okay, 100. What is Y2? From here to here, 20 plus half the distance. So what is that? 70 mm. Similarly, what is A3 value? This one. 100 into 20. What is Y3 value? 20 plus 100 plus 20 divided by 2. So what is that? 130 mm from bottom. Divided by A1, A2, A3. A1, A2, A3 is what? Area of a rectangle. 20, 100 plus 100 into 20 is equal to so the calculation y bar is equal to 61.429 mm. You calculate like this. Okay. This is how you have to do for the problematic parts.